Yes, and here are the two questions. One is when current of in primary coil changes from 5.0 ampere to 10 ampere in 0.2 second, an EMF of 60 volts is induced in adjacent secondary coil, calculate M. So we know ES is equal to minus M into delta IP upon delta T. So ES here 60 volt, and we have to find out delta IP means 0 minus 5.0 upon 0.2 second. So here 60 equal to minus plus 5m upon 0.2, minus minus plus. So m equal to 60 into 0.2 upon 5, 12 into 2, 0.2, 2.4 Henry. I am trying this question just for a practice of you, because students are unable to see what to do. So unless we do the question, we don't have the idea to solve. This was a simple question here. Now, number 2 question there. Current in primary coil is reduced uniformly from 10 ampere to 0 in 1 millisecond. Calculate the induced EMF in secondary coil. Mutual inductance of two coils is 5 Henry. Also, this is the important part here. That's why I am doing this question. Also, calculate the change in magnetic flux linked with each turn. With each turn of secondary coil of 600 turn. So first of all, you are asked to find induced EMF. So again, E is equal to minus M. Now, delta IP है, delta IP upon delta T. So E equal to minus M5. Delta IP it is 10 to 0, 0 minus 10 upon 1 millisecond, 10 to the power minus 3 second. 1 millisecond, milli, 10 to the power minus 3. So it is minus 5 into minus 10 upon 10 to the power minus 3. So it is how much? 50 into 10 to the power 3 volt. 50,000 volt. Yeah, bhai? And now you have to find out change in flux linkage, magnetic flux will be secondary coil. Further, you know NS phi S is equal to M IP. Therefore, NS into delta phi S is equal to M or delta IP. So delta phi S with each coil will be M delta IP upon N, and this come out to be M is 5, 0 minus 10 upon 600. So this is a change in magnetic flux linked with each coil of secondary. Delta phi S is the change in magnetic flux with each coil. So it is minus 50 upon 600, 0. Or minus 1 upon 12 Weber. So this was a simple question here, but this part is difficult for students. They are unable to think over this. Now I come to a very good question here. I like that question most because that makes so many things clear. Here in this figure, it is a battery, and here is distance 100 ohm. This is 200 ohm, 200 ohm, 100 ohm, and batteries of 3 volt. Batteries of 3 volt. And here we connect a pure inductor. Pure inductor of 10 Henry. 10 Henry. So here is a switch key. So you are asked if K is closed at t equal to 0. Number 1, find initial current. Initial current through 100 ohm. You find the initial current drawn from battery. It has been drawn from battery. Now number 2, potential difference. Potential difference, initial potential difference. Sorry. Initial potential difference across inductor. Number 3, final current drawn. Final current from battery. Yes, final current drawn from battery. And number 4, final current through 100 ohm resistance. So this is a question here. 3 volt battery, 100 ohm resistance, 200 ohm resistance, 10 Henry inductor. So you know, when just we close this key, currents are flowing, it will try to pass through inductor. Pure inductor means it has no resistance. Due to self-induction, back EMF is induced in the time inductor that opposes the flow of current. So initially the inductor will act bad conductor. So current है ना, initially पहला वार्ड है, initially दिखाई दे रहा और चलिए initially inductor act as bad conductor because of self-induction. So current will flow only in the circuit, and hence initial current drawn I equal to 3 upon 100 plus 200. I equal to V by R. यानी 3 upon 300 यानी 0.01 ampere. It is the initial current flowing. But later on what happens? Now we ask him it is a potential difference across inductor. Number 2 part. Initially the 100 ohm resistance and 10 Henry inductor are in parallel. So potential difference across inductor initially potential difference inductor is equal to potential difference across 100 ohm. That is equal to क्या भाई 0.01 B equal to I 0.01 into 100, so it is 1 volt. Then final current drawn from battery. Finally, when induced EMF, current start flowing here, saturation current flows. No potential difference will take place, and after some time, current through inductor becomes constant and no EMF E equal to minus L di over dt will be there and good and becomes good conductor. So this parallel combination by zero resistance or under the zero resistance right? And hence final current drawn from battery I equal to 3 upon 200 यानी 0.15 ampere. Then you are asked finally what is the current flowing through this. Finally inductor become a good conductor with zero resistance because no back EMF. So final current through 100 ohm is equal to 0 क्योंकि ये offer no resistance, तो current flows through that path in which it experiences no resistance. So this is another question here. Please solve these questions yourself at home. These are model questions here. There is one more question here. Here is a time varying magnetic field. Time varying magnetic field which is normal to plane board and into it. And there is circular loop here, connected to a resistance here, R. So you are given here in this figure, magnetic flux through coil perpendicular to plane of field directed is given by phi B, magnetic flux phi B, 6T square I think. 6T square plus 7T plus 1 milliweber. It is here milliweber. हाँ भाई, find the magnitude of induced EMF in the coil at t equal to 2 seconds. Find modulus E at t equal to 2 seconds. If resistance is 10 ohm, find current anti-direction. Find the current. Find current if R equal to 10 ohm, the whole circuit, and direction of current. Direction of current. What is equation telling you? Flux increasing degree with time. Yes, friend. Here flux is increasing or decreasing? So here flux is increasing because T तो flux increase हो रहा है, तो it means induced current will oppose the increase of flux, and this field is into, so induced current will be such that it should produce magnetic field outward. तो current तो एंटी फ्लो होगा, तो here current flows from left to right. ये तो डायरेक्शन सिंपल. तो मैग्नीट्यूड ऑफ P बराबर d5 माइनस d5 और dt. तो माइनस d अपॉन dt ऑफ 60 स्क्वायर प्लस 7t प्लस 1 मिली वोल्ट का होगा. मिली वोल्ट में होगा ये. तो इट इज माइनस 12t प्लस 7 मिली वोल्ट. इट इज माइनस 7, सॉरी ऐसे करते हैं, मिली वोल्ट. t इक्वल टू 2 सेकेंड निकालना है, तो पुटिंग t इक्वल टू 2 सेकेंड दिया, पुटिंग यूजिंग t इक्वल टू 2 seconds, modulus E इक्वल टू, it is here minus 24 plus 7 millivolt, यानी minus 31 millivolt, and hence current, magnitude of current I equal to modulus E upon R minus 31 upon 10 milliampere, यानी minus 3.1. मैग्नीट्यूड हर प्लस होगा, इसमें मिली एम्पियर. डायरेक्शन आई टोल्ड यू बिकॉज दैट इक्वेशन टेल यू फ्लक्स इज इंक्रीजिंग, तो इंड्यूस करंट विल ट्राई टू मेंटेन द सेम फ्लक्स, इट विल बी ओनली करंट इज आउटवर्ड, एंड इन कॉइल इफ करंट फ्लोज एंटी-क्लॉकवाइज मैग्नेटिक फील्ड इज आउटवर्ड. तो दीज क्वेश्चंस आर देयर, यू प्लीज do it. I will be solving more question in next videos.